Electrical diagrams. So there are two types of electrical diagram. One is circuit diagram or symmetric diagram. Second one is wiring diagram. One is used for electrician and the second one is used for planner or architecture. Okay, so let's see one by one each. So let's see circuit diagram. This is an explanatory diagram intended to facilitate understanding of details of operation of the circuit. And the diagram is drawn in such a way that it provides clean connection to the electrical points and they are easily followed. Means this diagram is used for understanding of operation and circuits. It is prepared as per IS 2032 part 1 1962, means before the amendment of 1983. There are following points to be considered for the drawing of circuit diagram. First one is supply line on the horizontal way and loads are on the vertical ways, means you have to always draw supply line on the horizontal line and loads on the vertical line. Switch moments are left to right. Always your moment should be from left to right. All switches should be drawn on off position, means you cannot turn on any switches on the diagram. Always turn on, don't turn on any switch on the diagram. All the switches condition should be remain off in the diagram. Means fourth condition, don't draw cross wiring, means you cannot cross wire anything in real. Okay, so these are the conditions for drawing circuit diagram. So let's see next is wiring diagram. In these wiring diagrams have prepared electrical installation connection. This is drawn as per IS 2042 part 1 1962. There are main two types of wiring diagram. One is multi-line diagrams. You can draw one or two or more lines in the multi-line diagram. And another one is single line diagram, means you can draw only single line diagram connection. So let's see examples of wiring diagrams. Here you can see the schematic diagram, right? Now here you can see the wiring diagram of this schematic diagram. Okay, and multi diagram also, and here is the diagram for the electrician, means in which direction they have to combine and wire for electrical sockets, ceiling rows and other components. Now testing of installation, they are done as per following. First one is general testing, second one is switchboard testing, third one is transformer testing, fourth one is cable testing, then motor and other equipment testing, and sixth one is wiring installation. Seventh one is most important one, earthing installation. Now testing of the following ways. Next is the testing of wiring installation. Means you have to ensure that each and every terminal is connected to each other and the line is returned to the neutral path. Here you can see line is connected to one switchboard, then energy meter connection line, and it is incoming from the supply line and it is going to the load condition one when it is going to the main switch, and from there it goes to the two-way distribution board. One is circuit number 1 and second one is for circuit number 2. All the switches are in on position in this diagram, means this is a wiring diagram which we had seen earlier, and one measure is also connected to measure the earth fault and earth resistance fault. It is always connected in line with the main switch. Here this is the one wiring installation, testing of wiring installation. In this way you can test your wire and installation. Now you can test your wiring with the help of measure. Now polarity test, means which one is line and which one is neutral. Means you don't know the connection of line and neutral. How will you know the connection of line and neutral, and how will you identify the connection? Means one line is given to the switch open and test lamp and earth. Now you can see the lamp holder is there. Now if lamp brights, then this is line, and if lamp doesn't bright, then this is the neutral. Now next one is vice versa connection. Lamp does not light. Lamp light switch is kept open here, and lamp holder is given to the neutral, and earth is terminated between these two. So this is called as polarity test, means which one is positive or negative in DC, but in AC which one is line and which one is given to the neutral connection. So this was the polarity test. Now next is testing of earth continuity and continuity path, means earth is continuously conducted with the path or not. Earthing is provided for the application or for the supply system is there. Testing of earth continuity path is conducted. Now here you can see the main supply and earth terminal of the consumer are given to the distribution board, and main switchboard is there, right? Now you can measure and test your earth terminal to the earthing continuity conductor, and it is given to the earthing connection. Now in this way you can test your earth and earth continuity path. Now next is measurement of earth resistance. Now you had seen the Murray loop test and Worley loop test in the previous semester. Now this is the summary of that test, and here there are three electrodes kept in the earth resistance. Electrode E, electrode B, B1, B2, and electrode A. In this way, one rheostat is connected to electrode A. You can measure the resistance of earth, and it can be placed at equal distance. Now next, here measure is used to measure the earth resistance. Okay, now here the construction of measure is there. Um, there is one DC generator which is used to operate the measure, and DC generator is connected to the rectifier circuit, and rectifier circuit gives the variation to the potential coil and current coil. In this way, there is one link which is connected to C1 and P1, and other link is connected to C2 and P2. Here you can see the DC current path and AC current path by different notation, means continuous notation is for DC current path, and discontinuous notation is for AC current path. In this way, measure is used for to determine the earth resistance. Now we'll see the economical consideration for illumination design. In illumination design, economical consideration have two factors. First one is initial cost, maintenance cost. Third one is energy cost. Initial cost means at the time of installation how much money we need it, and after the installation how much money we need into the maintenance of that cost. Energy cost means how much rupees bill will be generated by energy meter while consumption of that initial cost. Right, selecting the higher efficient lighting system. Following are the factors for the economical condition. First one, you have to select higher efficient lighting system. Second one, used higher efficient luminous source. Third one, take space to height ratio. Consider space to height ratio. Fourth one, controlling the lighting system in days. Means in days you can take the advantage of sunlight system, right? Next one is maintenance factor for and utilization factors in its limit. Next one is illumination is developed on job works. Next, color of the wall should be light. It should not be dark. Distance between the luminous and floor up to the 2.5 meter. Use LED and CFL lights instead of old lights. Used reflectors for higher efficiencies. So these are the economical consideration for illumination design. So let's see next. Design of lighting system. In this way, there are three methods for design of lighting system. First one is watt per square meter methods, means as per 1 square meter how much watts you consume. Second one is lumen or light flux method. Third one is point to point method. So let's see one by one in each. Next one is utilization factor. A surface to be utilized is to receive the light either directly from the lamps or from the ceiling or from the walls, or it should be get light from the reflectors. The total flux reaching to the surface will never be equal to the flux emitted by the lamp due to the absorption of light by the reflector. Means reflector will absorb the light in few. Okay, the light flux reaching through the working plane can be calculated by multiplying the total lumen flux emitted by the lamp and by a factor called utilization factor, and in this way utilization factor is utilized. So from utilization factor that you can calculate the multiplying total lumen flux emitted by a lamp. So next, depreciation factor. It is a ratio of illumination under the normal working condition to the illumination under the ideally clean condition is called depreciation factor. Its value may be zero point 0.8 or less than 8. Okay. So thank you. This was from the chapter 1. Thank you very much. If you have any query or question regarding this session, so please ask. Don't hesitate to ask any question. Thank you very much.